Hello and welcome to KISS Math. So far, all of our equations have been dealing with one variable. Literal equations are those that deal with more than one variable, like this. Y equals mx plus b. Now this is no different than an equation that only has numbers. It's just that the numbers are not yet known. If I never tell you what the values of m, x, and b are, then this is as far as you can go. But if I tell you that m is equal to 2, x is equal to 3, and b is equal to 4, well then I can substitute all these values in and solve for y. So I would have y equals 2 times 3 plus 4, which is just 6 plus 4 and 10. What you do need to pay attention to is which one of these variables are we trying to solve for. So, for example, we had y equals mx plus b, and so this equation is already solved for y. But what if I was more interested in this x? Well, I can solve the same equation for x by isolating it. And we do that by moving this b over to the other side and dividing off this m. So if I want to just solve for x, I'll subtract the b out and divide both sides by m. And now I have the same equation but solved for a different variable, x. Let's do an example. So here we have an equation, negative 2x plus 2 plus 3y equals 8. And it's telling us to solve the equation for y. So that means we need to isolate everything with a y on one side and move everything else to the other side. So the first thing I'm going to do is move this negative 2x and this 2 to the other side here. And I'll keep the 3y on the left. So we'll get 3y equals 8. And then now we move the negative 2x to the other side, get a positive 2x, and then the positive 2 to the other side becomes a negative 2. And I'll simplify this a little bit. So we have 3y equals, I'm going to put the 2x up front, and then I have 8 minus 2, so that's a positive 6. And now I have to divide off the 3. So if I do that, I'll just have a y now, isolated. And this whole thing must be divided by 3. Now, this is a valid answer, but another way to write this is to split up this fraction. So everything with the common denominator can be split up. So I can write this as 2x plus 3, 2x over 3 plus 6 over 3, which is the same as 2x over 3 plus 2. So this is still correct. A little bit more simplified way of writing the equation for y would be 2x over 3 plus 2. Now this example will show how some of these equations with multiple variables can be used in real life. Let's say if you're driving at a speed of 50 miles per hour, and let's say you were driving for 2 hours at this speed. So in that case, it would make sense that if you're driving 50 miles per hour for 2 hours, you would drive or have driven a total of 100 miles. But if you don't know the speed, nor how long you were driving, then all I could say is that you were going at some speed s for some amount of time t to travel a total distance, some distance, d. S times t equals d would be a way to represent the same equation except with the numbers unknown or not given. And now, what if I'm more interested in your speed than the distance? I could take this equation and solve for just the speed. So I could have s equals, and I divide off the t to get d over t. And now let's take these same numbers that we had and let's frame the problem a little bit differently. So let's say that, okay, you traveled a total distance of 100 miles and you were traveling for a total of 2 hours. What was your speed? Well, since we solved this equation for speed directly, we can calculate that. So if I plug in s equals d, which is 100 miles, over 2 hours, t, then I could say my speed was 100 divided by 2 is 50, and then our units, miles per hour, which is what we started with. The point I'm making here is that you treat these letters the same way as you would any other number. The letters are nothing more than symbols for numbers that aren't known yet. Alright, example 3. The area of a rectangle is equal to its length times its width. So A equals L times W. Express length in terms of the other two quantities. So that's typical phrasing from a word problem. Another way to say this is solve for length or solve for L. Because if you isolate L, that means you're defining length in terms of the area and the width, which are the other two quantities. So all we need to do is solve for L the same way we would do with any other number, right? So we had A equals L times W, and we just need to divide off the W here. So if we have A divided by W. So this would be the way to express L in terms of A and W. And the point of this example is to get you used to some of the wording that's in these problems. Alright, here's another example. We have an equation, it says solve for R. So there are no numbers in this one, which is fine. So I don't care about any other of these letters except R. I'm going to try and isolate R. Everything else needs to go on the other side. So here we have the T that needs to move to the left. So I'll have E minus T equals TRP. And so in order to isolate the R here, I need to divide both sides by the T and the P. So we can do that together, because another way to write this is T times P, or TP, times R. And remember, with multiplication, it doesn't matter the order you write these things. So in order to isolate R, I'll divide by TP, and then on the left side by TP. And so these will cancel. And so what you'll end up with is E minus T all over quantity, or T times P, equals R. This will be the last example. So here we have an equation and it's telling us find the value of A if T equals 3, R equals 6, N equals 2, and R equals 4. So this means we not only have to solve and isolate A, we then have to substitute all of these numbers in and find the actual value of A. So in order to isolate this a here, that's the only place where I see it, I'm going to have to start by getting this out of the denominator. So I need to multiply both sides by r, capital R, plus n, lowercase r. So the capitalization matters. Capital R and lowercase r are two different values, so you have to treat them like two different numbers. So anyway, we multiplied both sides by capital R plus nr, so I have to also do it on this side, right? Like that. So these will cancel out, and what you get is you have the r plus n lowercase r times your t, and what you're left with is the n multiplied by a. And now we just have to divide off this n, like so. And so essentially you will have, I'm going to move the a to the left side, a equals r plus nr times capital T all over lowercase n. So this is our equation for a, but the last step is to substitute all of these numbers because they're given, and it wants us to find the value of a. So let's do that. So capital R would be 6 plus n, which is 2. And then lowercase r is 4. And that's all going to be multiplied by t, 3. And then all of that will get divided by lowercase n, which is 2. So let's just simplify that. So 6 plus 2 times 8, which is 8. So times 3 divided by 2. Simplify a little bit further. I get 6 plus 8 is 14 times 3 divided by 2. This will be 42 divided by 2. And then finally, the final answer is 21. So that's literal equations. They're really not that much different than regular equations that you knew before. You just have to get used to dealing with a lot of letters at once.